looked at definite integrals and indefinite integrals in which you are anti-deriving just through basic rules. We've also looked at ones that are a little more complicated in which we have to use U substitution. With BC calculus, not in AB, but with BC calculus, there's also a next level to go to. There's actually additional levels, but and those would be ones like with rational expressions like this expression right here, where U substitution cannot help us. All right. Now, if we were to look at this and we say, and this problem, by the way, is give credit. This is by the author of Lynn McMullen. If we look at this expression right here, we have 2x plus 31 in the numerator. We have x squared minus 5x minus 14 in the denominator. Right. Now, with just U substitution, initially our brains might look at this and say, okay, can we use the natural log here with our antiderivative? We see that we have x squared minus 5x minus 14 in the denominator. The derivative of that is 2x minus 5, and unfortunately we have a 2x, we don't have the minus 5. And we can't just subtract 36 from the numerator only. It doesn't work that way. So we can't use the U substitution here, right? But what we can do is we can decompose this expression so that it is now in terms of a linear factor. And if that's the case, then we can go back to that idea of the antiderivative with natural logs involved. All right, so if we look at this expression, you look at that denominator, and your algebra brains are kicking in and say, okay, I've got x squared minus 5x minus 14. Could I factor that? And in fact, you could. Let me change colors right here. All right, if we look at this, we say, okay, well, this is actually x minus 7 and x plus 2. It's the product of those two binomials. All right, so what does that mean? Well, that means that this right here is actually this expression, 2x plus 31 over x squared minus 5x minus 14. That's equal to the sum of two expressions. One expression has x minus 7 in the denominator, and the other expression has x plus 2 in the denominator. Now, we don't know what's up here, all right? But if we can, right now, but if we can figure that out, well, then we can sub this expression out, and we can sub these two expressions in since they're going to be equal to each other. And now, if we're looking to do the antiderivative, well, we have a number up here, okay? And that number will be over x minus 7, and we can actually take that antiderivative using the rules that we've already learned. So that's the idea behind partial fraction decomposition, is to take some kind of polynomial factorable. It has to get down into linear factors that are not repeating. That's so in other words, it's not going to be x minus 7 squared. Okay, it's just going to be x minus 7 and then a different linear factor as well. There could be more than 2, but on the exam usually they give it 2, and sometimes they actually even factor it for you already. Sometimes you have to actually do the factoring like we just did. But you're going to take that more complex denominator and you're going to decompose it into two linear denominators that are connected through addition, and then we do our antiderivative. Okay, so this problem will take a little bit longer because we've got a lot of algebra to work through before we actually get to the calculus. We're going to do this problem in the next video.